Alright guys, today we're going to go over the 2.2 notes and examples. This is the green packet. Pretty much once you do this, you'll be able to do the homework pretty easily. So, that's it. Alright, so we're going to work on how to identify a polynomial function. It's really easy. You're going to look at the exponents. They must be a whole number. So really what that means, being a whole number, is basically when you look for exponents, no negative exponents, because whole numbers are always positive, including 0 and 0. No decimal or fraction exponents. And no variable exponents. If you see any of those things, it's not a polynomial function. It's still a polynomial. A polynomial is just math stuff. The function itself has to have a specific rule. Alright? So, we're going to look at the exponents. So, in 1 through 4, we're going to decide whether the function is a polynomial function. If so, write it in standard form, state its degree, type, and leading coefficient. This is basically your fire starter from today, so that's why the correct answer wasn't on the board. So, I'm going to look at number 1. Number 1, I'm going to look at the exponents. 4, that's a whole number. 2, whole number. All the exponents that I see are whole numbers. That means it is a polynomial function. Is it in standard form? Well, standard form means it has the biggest exponent first, then the next biggest exponent next, and then finally the smallest exponent last. And that's how this is. It is a polynomial function. It is in standard form. So now, we just have to find the degree, type, and leading coefficient. Well, the degree is the biggest exponent. That's 4. Because of the degree of 4, it's going to tell us that type just like in the box above. So, I actually don't like that color green. So, if you look in the box above, it says the type for the degree of 4 is quartic. And the leading coefficient, well, I look at the biggest exponent, which is x, or which is 4. The variable is x, so the leading coefficient is the number in front of that, which is 1. So that's it for number 1. Number 2. I have g of x equals 7x minus radical 3 plus pi x squared. I'm only worried about the exponents to see if it's a polynomial function. 2 and technically 1 are the only two exponents I see. Both those are whole numbers. So it is a polynomial function. It is not in standard form, so I have to rewrite it to put it in standard form. So I rewrite it as g of x equals, I put the pi x squared first, because that's the biggest exponent, then the 7x, then the constant minus radical 3. So now, this is standard form. Now that it's in standard form, I'm going to find the degree, which is 2, which tells me it's quadratic. That's the type. And the leading coefficient is pi. Now when we go later on this, when I find the degree, I'm not going to care necessarily about the number or the type. I'm going to care more that it's even. I'm going to care more that that leading coefficient is positive. We'll talk about that in a little bit. 3. 5x squared plus 3x to the negative first minus 1. As soon as I see that negative 1 is exponent, no negative exponents, not a polynomial function. That's it, done. 4, I have x as a variable, not a polynomial function. No variable exponents. And that's it for basically your fire starter and your green notes for the first part of your green notes. Alright, how can you graph a polynomial function? To graph a polynomial function, you have to find end behavior. So how can you graph a polynomial function? You're going to find end behavior. Remember, end behavior is the direction of the graph as x approaches infinity and x approaches negative infinity. That means as you look to the right and as you look to the left. To do this, we must find the degree. Tell me if it's odd or even. Leading coefficient. You're going to tell me if that's positive or negative. Alright, so once we do that, we'll be able to graph polynomial function. Alright, so end behavior is how the graph is basically going to act after our XY chart's done. Alright, so to finish the graph, we need to know end behavior. End behavior is based on a couple things, and it could have degree that is odd. It could have a degree that is even. Remember, that's the highest exponent. Now, the leading coefficient could be positive or negative. Positive or negative. That means you have 4 different combinations that could give you end behavior. So, for an odd positive, the graph is going to, as it goes to the right, it's going to go up. So if I made an XY chart, or if I made a coordinate plane, and odd, let's say I had y equals x. Alright, if I graph that, it would look kind of like this. As the graph goes to the right, the graph goes up. As the graph goes to the left, the graph goes down. And that's how that works with all odds that have a positive leading coefficient. So the graph is going to go down and to the left. The graph is going to go down and to the left and up and to the right. So basically what we're going to do is once we make an XY chart and plot our points, I'm going to put these arrows at the end of the graph. It's really simple. Now if it's negative, it's flipped. So it's going to go up and to the left, down and to the right. That's it. So think about it this way. If it's odd, the arrows are going opposite directions. If it's even, the arrows are going to go the same direction. Think about it this way. If I made a graph here, and I graphed something to the second power, it'd be a u. So, if it's even, it's going to go the same direction. If it's positive, one's going to go up to the left, one's going to go up to the left, one's going to go up to the right. If it's negative, one's going to go down to the left, and the other one's going to go down to the right. So, 4 combinations. You just got to know what those combinations do. We're going to use that to do our graphs. Alright, so to graph polynomial functions, the first thing you're going to do is you're going to identify so the first thing you're going to do is identify end end behavior. So that means you're going to have to find the degree and leading coefficient, and then look at that chart on the right above there. It's going to tell you how the arrows are going to go. The next thing you're going to do is you're going to make an XY chart. And that's it. Alright? So, number one. The first thing I'm going to do, number one, is I'm going to identify end behavior. So to find the end behavior, the first thing I need is I need to know the degree. This is already in standard form because the biggest exponent is first. The degree is 3. Now I really don't care too much about 3. I care more about it being odd. Now I'm going to look at the leading coefficient. The leading coefficient is -1. Now once again, I don't really care about -1 exactly. I really care that it's negative. So that tells me that this graph is going to go up and to the left and down and to the right. I already know that. Right? So now I'm just going to pick some points. I'm just going to pick -2, -1, 0, 1, and 2. I'm going to plug it in. So wherever I see an x, I'm going to put -2 in parentheses. So I'm going to have, for -2, I'm going to have y equals the opposite of -2 cubed plus -2 squared plus 3 times -2 minus 3. So -2 is cubed is -8 plus the negative, so it's going to be +8. -2 squared is +4, so 8 and 4 is 12. 3 times -2 is -6 minus 3. So it's -6 minus 3. 12 minus 9, which is +3. Do the same thing for -1. When I plug in -1, I'm going to get +1, 2, -4. Plug in 0, I get -3. Plug in 1, I get 0. I plug in 2. So once again, I'm just going to plug in, instead of x, I'm going to put a 2, so I get -8 plus 4 plus 6 minus 3. I get -1. So now I got my 5 points. So I'm just going to graph them. So I'm going to go left 2, up to 3, put a dot. -1, I'm going to go down to 4. 0, -3, 1, 0, 2, -1. Now, I'm going to graph this. Now remember, the biggest idea is this has to be smooth curves, not rigid points. So when I go from this one to I go from dot to dot, I got to make sure it's going to make a curve. So that means you have to be smooth about it. Now, I already feel that the graph wants to go down to the right, and I feel that it wants to go up and to the left. My end behavior actually agrees with me. So that's how I feel. So look, there's my end behavior right there. This part, I just graphed right there. And right here, this part, I'm going to graph right here. So my graph, I use the blue part from the XY chart, the red part from the end behavior. It makes a total graph. That's all we're doing. Alright, so the last example for these notes is I'm going to do number 2. So remember, when I graph, the first thing I have to do is I want to find the end behavior. So I need to know the degree. Well, the degree for this one, the biggest exponent, is 4. Remember, that's really important to me that because it's even. Now, the leading coefficient is the number in front of the x next to the 4. And that's just 1, which is positive. So according to my end behavior chart, this graph is going to go up and to the left and up and to the right. Now, if that doesn't work, that just tells me that I need to probably recheck something. Now I'm going to make an XY chart. Put -2, -1, 0, 1, and 2. I'm going to plug them in. I'm going to put -2 to the 4th plus -2 cubed minus 4 times -2 plus 4. Now, I don't have a calculator, so I'm just going to do it in my head, so I get 16 minus 8 plus 8 plus 4 so I end up getting 20. Now 20 is not really going to help me because it's probably not going to fit in the graph, but it is telling me it's going to go up and to the left. Which for the most part, that's actually really good. It's agreeing with my end behavior. Now I do the same thing, but this time I do it with negative 1. So I'm going to put negative 1 in for x. I'm going to do the same exact thing I just did, except I'm going to put negative 1 in for x. So I'm going to say negative 1 to the 4th plus negative 1 cubed minus 4 times negative 1 plus 4. Negative 1 to the 4th is positive 1 minus 1 plus 4 plus 4. I get 8. Plug in 0, I get positive 4. I plug in 1. So I'm going to do the same exact thing, but this time instead of x, I'm going to put positive 1. So remember, this is plug and chug like we did in the fire starter yesterday. So I'm going to put 1 to the 4th plus 1 to the 3rd minus 4 times 1 squared plus 4. So I get 1 plus 1 minus 4 plus 4. I get 2. Now I'm going to plug in 2. So I plug in 2. I get 2 to the 4th, which is 16, plus 2 to the 3rd, which is 8, minus 4 times 2 squared, so I get minus 16, plus 4, I end up with 12. So what are my points? If you want, you can make everything go by 2. You don't really have to change anything if you don't want either. So I'm going to make my y's go by 2. Which means this is 2, 4, 6, 8, 10, 12, 14, 16, so forth. So negative 2, negative 20, not on my graph. Negative 1, 8, it is on my graph right there. 0, 4, also on my graph. 1, 2, on my graph. 2, 12. So when I make my graph, remember, this has to be a smooth curve. I know this is going to shoot up all the way to 20. So I come down, I make a nice gentle curve. Right? So I just connect the dots. Now remember, end behavior tells me that it should go up and to the right, which it is. Even though it's going almost straight up, it's still going a little bit to the right. It's going up and to the left. So my end behavior was correct, right, according to the graph. And that's all we're doing. So this entire section, if it tells you to graph, find the end behavior, make an XY chart, connect the dots, add the end behavior. If it tells you to identify a function and put it in standard form, look at the exponents. All the exponents have to be positive numbers, not negative numbers, not decimals, positive whole numbers. And standard form just means you write the highest exponent first. So that's it for these notes. You guys will be working on 2.2 homework the next 2 days. All right, thank you guys.